ಒಂಚೂರು ನೀರು ಚೆಲ್ಲ ಕಣ್ರಮ್ಮ. ಅದು ಹ್ಯಾಂಡ್ಲು ನಾನು ಯಾವ್ದೋ ಮೂಡಲ್ಲಿ ಇಟ್ಕೊಂಡು ಓಪನ್ ಆಯ್ತು. ಫುಲ್ ನೀರೇ ಚೆಲ್ಲೋಯ್ತಾವ. ಅಲ್ಲ ಅದು ಓಪನ್ ಆಗ್ಬಿಡ್ತು. ಹಾ
ನೋಡಿ ಅಲ್ಲಿ ಅದೇ ಒಣಗಾಕಿದ್ದೀನಿ ನೋಡಿಕೊಳ್ಳಿ.
Good evening, Gayatri. Am I audible? Gayatri? Hello?
Hi, good evening, sir.
You're audible, sir. You're audible.
Are you?
Hello, sir.
Hello? Gayatri?
Yes, sir.
Am I audible? How are you, Gayatri? Hello? Good evening, Saujanya. Saujanya.
Good evening, sir. How are you?
Good evening. How are you, Saujanya?
Yeah, I'm doing good, sir.
Good. You are from which place, Saujanya?
Native, I'm from Vizag, sir, but my current working location is Nagpur.
Nagpur. Are you
Yeah.
right now in Nagpur or Vizag?
I'm in Nagpur, sir.
Nagpur. How is Nagpur?
Nagpur is cool now. Currently, we are experiencing too much of rain over here.
Can you talk to louder? Can you speak to louder? I am not able to hear you.
Am I
Saujanya.
audible now, sir, clearly?
Yes. Am I audible to you? How is my
Yeah,
voice?
you're audible. Yeah,
Okay.
you're audible.
Yeah, tell me. Go ahead. You are talking about Nagpur.
Yeah, currently we're experiencing too much of rains. Like from past 3 days, it's like floods and
Floods in Nagpur.
Yeah, even they
How come?
kept.
I think if you say flood in Vizag, I believe. But how come in Nagpur?
Yeah,
Nagpur,
even
is it a coastal area?
No. But from
Heavy
4
rain.
or heavy
rain.
rains. Yeah, from past 1 week we are experiencing it. So
Even same situation in Vizag, right?
no, Isaac, it's too hot. It seems my parents were staying there, right?
Okay. No, even Vizag is a coastal area, no? Coastal area.
Yeah, it's a coastal area, sir. It's a coastal area.
But even there we can expect heavy rain, flood, and all
Yeah,
those.
but currently it's not raining over there. From past 1 week, it's too hot.
But
it seems.
generally speaking, Vizag is very hot place. Very hot.
No, we don't experience that much. Only in summer we can experience. It's
Okay.
moderate.
Otherwise, a moderate temperature, you say?
Yeah, otherwise it's moderate.
Oh, very good. Vizag is very beautiful city, you know.
It's a very, very beautiful city.
Very good. But I have not seen, but I heard a lot about Vizag.
Yeah, it's a beautiful city. Like, we do have a lot of places to visit.
Yeah. And I heard that the capital of Andhra now is going to be Vizag,
Vizag,
rather than Amaravati. Am I right?
Yeah, yes, sir. Because, it's
But it is
gonna
not
be a
implemented. It is not implemented yet, right?
Yeah, officially it's not implemented yet.
But what do you say about that decision? It's a good decision, you say?
Yeah, it's a very good decision. Even a metro is also coming in Vizag only.
Okay, okay.
Yeah, and we have all the tourist
But
place
location
also.
wise, it's not correct. No, Andhra, it comes Vizag very extreme corner, right? That is
Extreme
one point.
corner
I say
and
that is a
yeah,
disadvantage. I say that is a
yeah.
disadvantage.
And other thing, disadvantage like IT wise, we don't have much companies over there. We have only limited ones.
Where you say Vizag?
Yeah, in Vizag.
Why? I think Vizag it must be well developed town, no city, no, right?
It's well developed city, but companies have not come yet. Recently, like 2 years back only, we had Infosys over there near our home itself. Yeah,
Uh,
like we do live in
okay,
outskirts of Vizag.
okay. I think that's a disadvantage. Correct?
Yeah, that's a great disadvantage. And people, we like staying in Vizag, no, we come to other cities. We don't have any job
Yeah.
opportunities over there.
I think that's not correct. I thought a lot of companies in Vizag, but in
No,
reality, that's not the case.
no, we don't have companies over there. We have
Mm,
TCS and Infosys.
I
That's
think
it.
in an entire your continent, Telugu continent, except Hyderabad, no cities got that kind of companies. I think in Vijayawada, you see some companies are there. Vijayawada.
Vijayawada, I don't know, sir, but I know only HCL in Vijayawada because I had a training over there. So yeah, I know
Oh,
about
okay.
HCL in Vijayawada.
Only HCL is not a good one, right?
Yeah, that too. It's an outskirts only. In Vijayawada also, it's
Outskirts.
in outskirts area,
Mm,
not in a complete
okay.
city.
I think
Yeah,
only Hyderabad. Hyderabad is enriched of IT techies. Correct, no?
yeah. Hyderabad is good, but cost of
Mm,
living in Hyderabad is also is very high.
but Hyderabad, you cannot. No, you are a Andhra, right? Hyderabad, it belongs to
Yeah, yeah.
Telangana.
Yeah, it belongs to Telangana. Even I'm as per my opinion, it's better to be in Hyderabad only because I came to North and I know the feeling how it will be. I can't adjust even food also over here.
Where food also you not adjusted in the Hyderabad.
No, no, in Nagpur I'm saying Hyderabad is good for
Oh,
food and
Nagpur, yeah.
everything.
Because I tell you, you
Nagpur is
Andhra, you're all spicy, Saujanya, spicy.
yeah, yes, sir. We
You
do it
can't
more
expect
spicy.
such spicy in Nagpur.
Spicy is no like we do it like the chili spice and these people eat that masala spice more. Even this food is
You take
spicy.
chili. You take more chili.
Yeah, we take more chili, but
But
here it's
Nagpur
like
people, if they take chili, they will gone. They gone.
yeah, they can't eat our food. I do, yeah, have some of my colleague friends, right? When I prepare something and give it
No,
to them,
you
they'll
take
say,
Saujanya, you take more rice. But Nagpur people, they don't take much more rice. They take more
"You-
chapati.
yeah, they won't take rice, sir. They'll take rice in a very little quantity. That
Ah,
too often, more often, not daily also. Maybe
but
weekly
you
thrice or
people, you
like this.
cannot digest without rice.
Yeah, we can't, be eating
You
with only
cannot fill
chapatis.
stomach without rice. Even Karnataka
Yeah,
also.
yeah.
Very good, Saujanya. Nice talking to you. Very nice
Welcome.
talking to you. You spoke very openly, Saujanya. Very good.
Thank you so much, sir. I'm glad to talk with you.
Good, good. Then good evening, Gokul. P. Gokul, how are you, man?
Good evening, sir. Fine. What about you, sir?
Fine. Where are you, man, Gokul?
I'm from Madurai, sir.
Madurai. Madurai
Yeah, sir.
Meenakshi.
Yeah, sir.
Okay. You're basically from Madurai?
Yeah, sir. Madurai is my
Working
hometown.
location, Gokul?
Same, sir. Madurai.
Hey, you are lucky, man. See, Saujanya, she's struggling. She's from Vizag, but she is in Nagpur. She is not adjusted with food. But you are
Yeah.
lucky.
Sir, actually, I want to explore more things, sir. I want other locations than
You
Madurai.
like traveling?
Yeah, sir.
Then you take a mutual transfer with Saujanya. Let her go to Vizag, you go to Nagpur.
Yeah, sir.
Very, very good, man. And today, sorry, because morning I had some my personal work I could not take, so I thought let me postpone the class at 6:30. Okay. But not a very convenient time for you, Gokul. Okay. Anything you want to say, Gokul, man? Gokul, any other things you say?
Where are you, sir? Where are you from?
I'm from Bangalore. I'm
Okay.
basically from Karnataka. I'm sitting in Bangalore, man, Gokul.
Okay.
Okay.
Yeah,
And
sir.
I'm working one of a premier institute, one of the best private engineering college in the country. I'm working for it. And I'm also a part of Bitch Pilani from past so many years. Almost, I'm a senior visiting faculty for Bitch Pilani. And this is how my journey started from long back. So every Saturday and Sunday, I'm always engaged. Gokul. I'm basically from Bangalore. But my native place is Mysore, but I settled in Bangalore, Gokul.
Yeah,
Anytime
okay.
you visited Bangalore, Gokul,
No, sir, not yet.
hopefully in future, let's meet in Bangalore, man.
Yeah, sir. Sure.
Good. Very nice talking to you, Gokul.
Yeah, sir. Sure.
Good evening. Good evening, Varshita. How are you?
Good evening, sir.
Varshita, are you there?
Yeah,
No voice. Can you speak loudly, Varshita?
good evening, sir.
Good
Sir.
evening. Had your tea, coffee, Varshita?
Oh, sir, I won't like.
Sorry? Hello?
Usually, I won't take tea or coffee, sir.
Why? That's good practice, man. What do you take then
Just
in the
snacks
evening?
like biscuits.
Biscuits. Varshita, you are from which place, Varshita?
Currently, location Chennai.
Chennai, Tamil. You
Yeah,
are from
sir.
which place? You are from which place?
Telangana, Hyderabad.
Telangana. Okay. So almost different region.
Yes, sir.
What do you say? What do you say? Namaskaram in Tamil, Varshita.
Vanakkam.
Vanakkam, Varshita. What do you say in Telugu?
Namaskaram.
Namaskaram. See, Telugu and Kannada look similar, man. You know? You understand?
No.
Telugu and Kannada look similar, and you can read Telugu. Even I don't know anything about Telugu, but I read Telugu word. Varshita. Correct?
We don't know Kannada, sir.
You don't know Kannada, but have you read the Kannada word? No?
Ah, yeah.
Correct, no? See, in southern states, Telugu and Kannada look similar, Tamil and Malayalam look similar. What do you say?
We know about Tamil and Malayalam, sir. We heard
Very good.
here.
Have you seen any latest? Who is your favorite actor? Telugu, Varshita?
Vijay Deverakonda, sir.
Vijay Devarkonda. Oh, good. Very good. So today we are going to have a first class, Varshita, digital design. Before that, very nice talking to you, Varshita. Then let me say good evening, Fatima. Good evening, Mayappan. Hello, Mayappan. Good evening.
Good evening, sir. How are you?
Fine, man. Thank you. With all your wishes, I am doing good. How are you, Mayappan? Where are you?
So, I'm at Madurai and I'm doing great.
Madurai. Oh, Madurai. You and Gokul are neighbors. You are sitting in the same place, Mayappan?
No, no, no,
Oh, good.
no.
Your
I'm living,
working location, Mayappan, same? Madurai?
it is Madurai, yeah.
Hey, fantastic, man. Madurai is very popular for temples, right? Right? If you see the
Yeah,
history,
yeah,
Madurai is completely ruled by Pandyas, Pandya in the history.
yeah.
That is why, you can see all Shiva temples. Madurai Meenakshi is a very popular, very famous temple in southern India. Yes or no?
Yes, you're right.
Hey, good, man. Good. Very nice talking to you, Mayappan. Sarika Pandey. Good evening. Sarika Pandey. Sarika Pandey, are you there? And to one more
Yes,
Varshita,
sir.
P. Varshita. Sarika Pandey, good evening.
Yes.
Say hello.
Uh, hello, sir.
Tell loudly, ma. Sarika Pandey. Hello, Pandey. Sarika. Good evening.
Good evening, sir.
Sarika, you are from which place?
Noida.
Noida. Are you right now? You're sitting in Noida
Yes, sir.
and working location, Sarika?
Noida, sir.
Both Noida. Okay.
Yes,
How
sir.
is Noida, Sarika? How is the climate there?
Very hot. Sir.
Very hot. But in
Yes,
Bangalore, we are cold. We are. It's very raining here. Is it summer in Noida,
yes, sir.
Sarika?
Yes, sir.
Oh. What is the temperature there?
33 degrees.
Oh, 33. My goodness. Very hot then. In Bangalore, very raining here. Very cloudy weather.
Oh,
Good.
yes, sir.
Nice talking to you, Sarika. Anytime you visited Bangalore, Sarika?
No, not yet, sir.
Oh, good. You don't like traveling? You
No,
like
sir.
traveling,
Yes, sir, but I not visit
but
Bangalore.
you didn't get opportunity. You should get
Uh,
opportunity. Correct, na?
yes, yes, sir.
Yes. Good evening, Varshita P. I think two Varshita here. Varshita Chintala. Varshita P. Say hello.
Yeah. Artist में
Var-
exam.
Varshita P. Varshita P.
Just now I spoke with you, sir.
Oh, is it? Then what about Varshita Chintala?
Hi, sir.
Hi, Varshita Chintala. You are both of you are from the same place, Varshita and Varshita Chintala.
Yeah, so maybe
Oh,
like I'm also from Telangana.
Telangana. Okay, which place? Vijayawada. You say
Sorry, sir.
Telangana. I think Vijayawada is not part of Telangana. Correct, na?
It's part of Andhra, sir. Andhra Pradesh.
Andhra. You are from
Yeah.
which part of Telangana, Varshita?
Sir, Jagityal. It's like near to Karimnagar district.
Please come again once again. I think it
Jagityal.
looks. Sorry.
Jagityal.
Oh, it's difficult to pronounce. First time
Yeah.
I heard this. Is it a town? You say
Yeah, sir. It is a district city.
district nearby
Yeah.
Karimnagar. Karimnagar is a district. I know.
Yeah, nearby that. This is also
Nearby.
district.
Good,
Yeah.
good. And is it near to Hyderabad, Varshita?
Sir, 3.5 hours or 4 hours apart from our
Then
Hyderabad.
it is quite far away.
Yeah.
Correct, no?
Yeah, sir.
Which are the nearby places?
To Jagityal.
Sorry,
Sirsilla in Karimnagar.
Karimnagar. Then
Next.
okay, you tell me which is the popular. Your place is popular for what? Famous for what?
Nothing is famous here, sir. It's just a city, small town, small city. That's all.
And there must be some significance, right, Varshita? It must
Mm,
be well known for this and that. Every place is like that only. How come it is just normal? Maybe any. What is the speciality of your place? Any maybe. Uh, is it a tourism place or something else?
Nothing like that, but there are some like famous temples near,
Oh, is it which
like
famous
some
temple?
temples.
Which
Mm,
which god? Famous temple.
there are like Krishna temple, ISKCON. There is an famous
Oh, very good, very good.
ISKCON
ISKCON,
temple.
Krishna temple. Okay.
Yeah.
So very nice talking to all of you. Myself, Dr. KB Ramesh. I am sitting from Bangalore, and today is the first class digital design. Okay. Uh, One second. Vashita, are you able to see this slide, please?
Yes, sir.
The, okay, good. You can see here the title of the course, digital design. Okay. If you look at this title, there are two things. One is a digital part and another one design part. Okay. If one of you can you tell me what exactly the concept of digital technology? What is digital? I think digital is a very common word. Uh, Maybe somewhere we heard that there is a slogan, make India digital India. And maybe somewhere you say the technology is digital, is advanced one. That's what. The where is the word digital is coming from? It has come from, I say, it is electronics. This is nothing but electronics technology. All of you know what is electronics. Earlier there was a electrical, now we say electronic technology. I think today, if you ask me what is electronics, then I say it's a Brahmanda. What it means that today no technology without electronics. We cannot think of technology without electronics. That means to say our human life is full of electronics only. Whatever you see, whatever the technology we are able to access today, that is nothing but electronics. I think you say that electronics engineer it has got a great scope. Electrical people, they speak always in terms of current, but we speak in terms of electrons. I think you understand that. This electronics, I say, is classified into two things. It is classified into two things. What is that? One is analog electronics and digital electronics. Is it not? These two are very common, even in the industry also. The people say I'm a electronics domain, analog domain, digital domain. Sometimes we say it's of mixed domain. Okay. So analog and digital is very common terms in the industry today. You understand? One of you can just tell me what exactly analog and what exactly the digital. Any one of you can put your answer in the chat box quickly. Can you do that? Hello, Gayatri, can you tell me what exactly the analog and what exactly the digital? Gayatri, can you say something about it? Or you say, sir, very odd time. No, I'm not in a position to answer anybody. Hey, what Gokul man? Can you tell me, man, what exactly analog and what is digital, man? Can you say something? Gokul Garu. Mayappan. Mayappan. Say hello, man.
Yes, sir. Yeah.
Mayappan, can you tell me, man, have you heard of these two things, analog and digital, man? Or you say, no, sir, I never come across these two. What do you say?
I have come across analog and digital terms.
No, you don't know anything about analog and digital. You say sometimes my television set is digital one. Sometimes you say that my cable connection is a digital one. And wherever you go in the hospital, you say a digital X-ray, digital ultrasound, digital so many things. Am I right? Correct. Very
Yes,
common word, man. Digital. Yes or no? May happen.
Yes, sir.
That's what it is. Sarika Pandey, can you say something? What is analog, ma? What is analog? Sarika Pandey. No, you, whenever I say your name, whenever I call your name, you should respond, man. At least you should say, yes, sir, no, I am not able to. I think that kind of a dialogue is very much required from you people. Otherwise, it's very difficult for me whether you are following or not. What, Sarika? What do you say? Hello?
Yes, sir.
Can you say something about analog domain, Sarika?
No idea about that, sir.
No idea, you say. Sir, no idea, only get idea. Right, sir? See, whatever questions I am putting, putting you people, all very basic kind of things. It is not like a very rocket science technology. Already you come across. My intention is that I want to trigger your mindset. I want to trigger your mindset. At least you should look into that. I think that's what my intention. It is not like why sir is calling my name again and again. Don't feel that way. Because you are sitting in Noida, I am sitting in Bangalore. We are not able to see each other, Sarika. But how to connect effectively, that is the biggest concern I am facing today. Do you understand, Sarika?
Yes, sir.
So at least for that, you should try to find out what exactly at least can you look into Google, your helpline? Can you search very suitable answer for this and can you post it in the chat box? Let me see at least. I think that you can do, no? You can explore answer, right?
Yes,
Can
sir.
you do all of you? Quickly, let me see your answer. What exactly the analog domain? Do it fast. Hello, any one of you? Varshita Chintala. Can you send me the answer, ma, quickly?
Yes, sir. I'm typing.
Good. Chintala, one thing you understand, whatever the teacher asks you, you should respond.
Sure,
You
sir.
understand?
Yeah, sir.
That is the first thing you should do it. No, it is not. I'm telling you, it's a general appeal to all of you. Yeah, let me see the answer. Fantastic. Apurv Ranjan. Hello, Apurv Ranjan. Analog refers to circuits and signals that handle continuous values. Fantastic, man. Analog is an electronic communication or device that uses signals. Fantastic, Varshita. Uh, absolute. Absolute, what I should say, I appreciate your initiative. I think this is very important. Being a student, whatever teacher asks, you should try to find the answer. Nikhil Mayappan, analog domain. The analog domain deals with continuous signals, values that can vary smoothly over time and take on an infinite number of possible values within a range. Hey, fantastic, man. Nikhil Mayappan. Fantastic, man, Nikhil Mayappan. You understand? Good. So now let me put it like this. So one is analog, okay, and the digital. Analog. What is analog? Let me put it like this. Maybe something like this analog. There is a continuous variation. Continuous variation. And digital is something like this 101011011011, something like this. What may happen? You understand? If you look at this, the first one, there is a continuous changes over a period of time. That means, as Varshita said, as Mayappan said, as Gokul said, absolutely. What is analog is that there is a continuous variation of the signal over a period of time. Like this. You understand? I think I've shown very simple. You might have seen maybe you might have seen similar waveform in hospital. Maybe ECG signal is connected to ECG is connected to heart. Then you can see ECG waveform. You might have seen somebody's EEG electroencephalogram. You might have seen EMG electromyogram. You might have seen some other variation. Correct? No? You might have seen somewhere. This is what analog, please understand. And what is digital is that instead of telling a continuous variation, we are going to make it just 101010, something like this. That's all. So maybe if you want to put it in the waveform notation, maybe we can say like this. The ground is 0, okay? Then when it goes high, 1. A 1 means a plus 5 volt. That's it. Nothing to worry. Then again it comes down 0, 1, 0, 1, 1, 1, 0, something like this. That's all. That's all the difference between analog and digital. Please understand this. So if you see these two very closely, one thing you can come to conclusion is that you don't find such variation in digital, only a 1 or 0. That's it. But when it comes to analog, you can see a continuous variation. Is it not? It takes infinite values of infinite amplitude values, I say. Amplitude. That's all the difference. You understand? Varshita, you got it? And one thing is that any natural phenomena is what analog. Please understand. What is natural on its own existence? The natural phenomena is what? On its own existence. That is what analog. Say for example, I am telling you temperature. Just you take today's temperature from morning 6 o'clock to evening 6 o'clock. I think we got a different values, is it not? We got a different values. You can plot like this. At one point of time, 27, I think she was telling to me, She was telling to me, Sarika Pandey, the temperature was in Noida was very high, 33 degree. 33, 31, 32, continuous variation. I think the temperature plot was a classic example of analog. You understand? So when it comes to digital, only two values, 1 or 0, 1 or 0. Then you tell me which one looks very simple for you. Which one looks simple for you is that I am telling you by seeing these two, I am going to answer on behalf of you. I think you said digital looks simple. Digital looks simple. Is it not? That is what 1 or 0. You understand? Correct. See, I tell you one example. Take your marks. All of you are in first semester or second semester. I think what marks you are going to get at the end of the semester. We call it as SEE, semester end examination. I think if you look at that category from 0 to 100, 0 is one extreme, 100 is another extreme. Between these two extremes, then we got a huge variation of values. Is it not? Maybe 1 to all possible values. I think this kind of discrimination looks very difficult from the point of examination system. If everybody wants to discriminate like this, 1, 2, 3, 31, 35, 97, 98, something like this. Otherwise, what best can be done? You make two categories. Any value between less than 35, you say fail. Any value above 35, below 100, you say pass. I think very nice discrimination, very easy discrimination. That is what I say, it belongs to digital. You understand? So since in the digital you got only two values, up to some value, you get low. After that value, you get high. That's it. No other further discrimination. But unlike in analog, you have all kinds of variations. That is why analog looks somewhat very complex for you. You understand? So this is what the basic difference between analog technology and digital. I say digital is what something uh, evolutionary technology. It is a evolution, evolved recently. I say you can say modern technology. Maybe I can say a small conversation between two person. Name of the person is analog and the name of the second person digital. They had a small conversation. A digital asked the analog, "How old are you?" Then analog said, "I am around 200 years old, but still I'm doing good, but I'm facing a lot of competition." Then analog asked digital, what about you? Then digital said, I am around maybe 50 years. I don't know what is the future mine, but right now I'm doing good. That is what he said. I think you can understand the comparison between analog and digital here. You understand? So analog is a quite old technology and it is a very complex technology. I say very complex technology. But digital is, they made it, I say, new one, easy technology. If you compare these two, digital is very easy to understand, easy to design, easy to, what I should say, implement. That is why the man is, migrating, I should say, migration from the analog to digital, you know, because of its simplicity, because of its easy understanding. And it is a human tendency, man. So nobody wants today complex. Please understand this. Nobody wants complex. We want very simple. I tell you one example. Say, for example, you come to me for certain a discussion. I made it complex. Definitely, you don't come to me tomorrow. You turn up. You turn around to some other faculty because you need in a simple way. That is a human psychology. You understand? So nobody wants complex today. Nobody wants complex platform. We look for easy one, how simple way, how easiest way we can understand, we can design, we can develop. That is what this digital. Please understand this. Is it clear? What, Gokul? Any questions to me, man? Gokul, is it clear to you, man?
Yeah, sir. All good.
Very good. How is my sound, man? Are you able to listen carefully?
Yeah, sir.
No,
Absolutely.
what I mean to say, the connection is proper. Are
Yeah,
you
sir. Yeah.
able to listen to me very clarity?
Yeah, sir. I can follow you.
Good. Varshita Chintala, what do you say?
Yes, sir.
No, what is your any question?
No, sir, it's clear. Everything is fine. Yeah.
Everything is fine. You say. You say no question, sir. Only I have an answer. You say, Varshita. It's not like that. Okay.
Yes.
This is what our discussion in the semester. We are going to talk about the digital, the importance of digital. Please understand. But I don't say that you don't get a supreme answer in analog. Please understand. You get a very clarity answer in analog. You get a very accurate answer in analog. But the problem with analog is that, what I should say, difficulty. It's not easy. I'm telling you. I give one more example. If you take one street, you get maybe 10 expertise on digital, Varshita. You get, but hardly to find one expertise on analog. That's how it is. I think even teaching analog is not easy. Convincing analog technology to the student is not easy, Archita. Please understand this. But digital is easy. That is why everybody is picking digital. Please understand. You got my point? So
Yes,
this
sir.
is what the clear-cut difference between analog versus digital. Now, only we talk about digital today in the semester. Okay, how to design the digital circuit, how to implement digital circuit, and what are the types of digital circuit, and that is what the objective of this course. Then if you ask me a question, sir, where is digital circuit? Can you tell me one example for the digital circuit? Then I say the easiest answer is your computer. What computer you have connected right now for this class? Maybe some of you connected through a laptop, some of you connected to the desktop, some of you connected to the mobiles. All are digital devices, the classic example of digital devices. Apart from this, maybe all of you, your fancy of taking your pictures, camera, digital camera, very wonderful example. You understand? Today, technology is a digital technology. Please understand. Your TV is a digital TV. Your cable connection is a digital connection. Your X-ray machine is a digital connection. Your ultrasound is a digital one. You get more clarity. Please understand this. You get a very good output at easy technology, easy design. That is why I say that digital technology is dominating in the society. Everybody is talking about digital. I think you might have heard one more. There is a, what I should say, I forgot that. What is that one more technology now we are talking about digital? Again, zeros and ones. What is that? Hello, one of you can recall me? Can you connect? What is the technology? That is also zeros and ones. Okay, I'll catch up later on. So this is what the analog and the digital. You understand? Gokul? Hello? Gokul, you understand, man?
Yeah, sir. Yeah, sir.
Okay. So what is digital? Only you come across the signal zeros and ones, no other values. Just for easy to understanding, you can say your evaluation system is like pass and fail, no other discrimination. Gokul. 0 to 35, below 35, we say only fail. We don't discriminate how you fail, what is the value of it. Any value above 35, just we call it as pass. I don't say distinction, I don't say distinction, first class with distinction, no other discrimination. Any marks above 35, I say pass. Any marks less than 35, I say fail. I think that is the best discrimination, no other. It looks like digital. You understand? That is why the digital looks easy for people. Please understand. Now, I'll move to next step. What is digital circuit? See, if you take a digital system, I say, the digital system, okay? The input to this digital system, maybe again zeros and ones, 0, 1, 1, 0. This kind of data we called as binary. You must be knowing this term, binary values. What is binary? Zeros and ones. It process this. So then again it is binary. That's all. Any circuit handles the data this way. We can call it as a digital circuit. We can call it as a digital system. We can call it as a digital system design. Many terms. Even we say sometimes logic design. There is a logic. Sometimes we call it as a digital electronics. All same. All terms deals with same concept. Please understand this. Is it clear? Got it? Now, the types of digital search system. What is that? Types. I hope all of you, whatever I'm telling, you are recording it. Apart from my record, better you should have a pen or pencil with a notebook. Whatever I say, please scribble down. I think these are all the key points. Types of digital circuit. The types of digital circuit are like this. One is what we call it a combinational circuit. A combinational circuit. The second type is what? Sequential circuit. Please understand. Combinational circuit and sequential circuit. Then Gokul question is that, sir, I do agree a combinational circuit and sequential circuit. What is the difference between these two? Okay. What is combinational circuit and what is the sequential circuit? One of you can tell me the answer. What is combinational circuit? Gokul, can you tell me my answer? Oh. What is combinational circuit? Anushka Yadav, can you reply? What is combinational circuit? So what is combinational circuit? Apur Ranjan. A combinational circuits are digital logic circuits whose outputs are solely determined by the current combination of inputs. Fantastic answer, man. Apur Ranjan. So what Apurva Ranjan said, I give a one classic example. I do conduct a very surprise quiz to all of you. You don't like it. Not only you, any student don't like surprise quiz. Please understand. So I am going to give a grade for that. I am going to give a grade. That grade depends on your performance, what you perform. That's it. I don't consider any previous kind of things. No such things. That is what combinational. So grading purely depends on your today performance. No instant performance. That's it. No other things. You understand? See, again, if you see there is a match is going on between India and England. The result is purely depending on the today's performance. If they played well, I think the match result is going to end with draw. Correct, no? We are not going to consider what performance you did in the last match or previous to that. No, based on that, we are not going to evaluate how you are going to play. So based on that result declaration, if you played well, I think you can save the match. Otherwise, gone. Yes or no? Same way. That is what combination. What, Vashita? What do you say? Correct? Huh? That is what
Yes.
combination. There is no a past input. There is no previous input. Please understand. That's it. I give a best example for that. I give a best example. If you take a adder, say for example, if you take a adder circuit, off adder. Okay, take two inputs. A, B, 0, 1, sum equal to 1, carry equal to 0. See, this result is depending on this input, no other past input. Please understand. Now I change input like this. I give 1, 1. What happens? Sum equal to 0, carry equal to 1. We got new result. This result is depending on the not previous input, the present input. This is what combinational circuit. Chintala, Varshita, Apurva, Ranjan, please understand. What answer you have given is absolutely correct. Just I'm trying to put it in a different dimension here. What is combinational circuit? Output at any point of time, it depends on the present, no past, no future. There is no question of storage here, only instant. Maybe I can give a classic example here if you want to connect this concept. Say, for example, if you take a voltage across a resistor, you take a resistor. I think all of you know resistor. What is resistor? It has got some resistance to flow of current that you know. Say voltage, the value of resistance is fixed. Say, for example, you take 1K, man, 1K, 1 kilo ohm. Okay. Then the voltage across of this resistor, V of t, it is depending on I of t. What is the current at that time? Yes or no?
Yeah.
Yes, that is what combinational. Voltage at any point of time is depending on what is the value of current, because the value of resistor is fixed forever. Yes or no? So this is what I say combinational circuit. You got it? I give one more equation you might have seen. The voltage across capacitor, one more electronic component, 1 by C integral minus infinity to t and I of t or I of tau d tau. You understand what it is? What it means? You see, man, minus infinity. It means that it depends on the previous charge, the storage of charge. That means not only present and the previous charge. If you say previous charge yesterday, day before yesterday, there was some value, you have to hold it. You have to hold it. So this is what I say VC. This VC is totally different from VR. VR is absolutely combinational and VC is not combinational. It is a sequential. It means what? The output is depending on the present and as well as the past stored value. Storage, holding the value, previous value, recording. Wherever you say recording, wherever you say storage, wherever you say yesterday, it means what? Sequential circuit. That means you have to hold the value. I come to the same example. If I want to declare a rank of you, not only your today's performance, I'm going to consider your past, previous semester performance also. I'm going to consider your yesterday, day before yesterday, and previous month performance to declare a rank. I think that is the procedure. If the university wants to declare rank not only 8th semester, not only 8th semester, along with 8th semester, 7th semester, 6th semester, 5th semester, 4th semester. You understand? So what it means, not only present and the previous values, where it is stored. It is stored somewhere. If you say it is stored somewhere, means in the digital system, there is a memory. What is memory? Register. What is register? A cascading of flip-flops. Cascading of latch. Flip-flop and latch. It is a big discussion in the coming classes. Please keep it in mind. Latch or flip-flop is a storage device. At any point of time, it holds bit of information. Bit of information. You understand? So that is what the difference between combinational and sequential circuit. Is it clear, Varshita? If you have any questions, let me know. Please put it in the chat box. Apurv Ranjan, Anushka Yadav, Saujanya. Saujanya Garu, can you tell me what is your question? Saujanya, say. Gokul from Madurai. Come on, man. Who is that? Mayappan? Nikhil Mayappan. Say
Yes, sir.
something, man.
Yeah. Could you please repeat
What do
the
you say,
question?
man? Mayappan? Are you following, man?
Yeah, could you please repeat the question?
My question to you, you have any question?
No, sir. So far,
No.
good.
No problem. It's going fine, you say?
Yes, sir. I could follow it up. Yeah.
You ask me one question, man. Any one question related to the subject now. Anything. It's a very serious question, very generic question, whatever. Please ask one question.
Okay, sir. That would be state five differences between company.
Come again, once again. Please talk loudly, man.
Yeah. 3 points on the difference between combinatory circuits and sequential circuits.
Sorry? 3 points.
Yeah.
On?
The difference between combinational digital circuit and sequential digital circuit.
A combinational circuit may happen, no storage element, please understand. Output is depending on the present input, only the value of present input. You understand?
Yes.
The classic example I'm telling you, you might have heard gates, logical gates. The basic
Yes.
gates, you understand?
Yes.
That is what combinational circuit. And if you take any arithmetic circuit, say for example, adder, subtractor, multiplier, divider, then you take parallel adder, then you take multiplexer, demultiplexer, decoder, encoder, then magnitude comparator, all this. A classic example of what I should say combinational circuit. There is no storage. If you take any circuit in which, if you see a flip-flop, a latch as a part of the circuit, a flip-flop latch is nothing but storage devices may happen, then you can say sequential. I'll tell you one classic example for this. You take a counter, say for example. What is that?
A counter.
Counter. Say for example, initially 0. Counter value 0. To this 0 plus 1, you add 1, you get 1. Again, you take the previous value 1. To this, you add 1, 2. And again, you take 2. Previous value plus 1, 3. Then again, you take 3 plus 1, you get 4. Then 4 plus 1, 5. It goes like this. What it means? Initially, previous value, okay, add the current value, you got 1. Again,
Yes.
you take the previous value, add 1 to this, you get 2. Again, you take the previous value, add 1 to this, you get 3. Again, you take previous value 3, you add 1 to this, then you get 4. Again, you take previous value 4, add 1 to this, 5. What it means that you are considering the previous value and the present value. Correct? Mayappan?
Yes.
Yes or no?
Yes. Yes.
This is what sequential, man. Because this one is you stored somewhere. This 2 you have stored somewhere. You have stored 3. You have stored 4, 5. So count is a sequential. You understand?
Yes, sir.
Yes. So the classic example for sequential, you can say flip flop, then latch, flip flop, latch, then I should say counter, then register, like this. Got it, Mayappan?
Yes, sir.
That's all, man. That's all. I think you feel looks very easy concept. Correct, no?
Yes. Yes.
That is why people like digital system. That is why people like digital design, because of its simplicity. You may not get this simplicity in analog. You understand?
Yes, sir.
Okay. Any other question, man? May happen.
No, sir. Nothing else.
Very good, man. Very good. Now, what I do, I come to the basic. Then you ask me a digital circuit. If you take a digital circuit like this, maybe just an example, just I have outlined. If you do consider it as a digital circuit, what is the basic building block? Please note down which is the basic building block. Basic building block of a digital circuit. Can you answer to this question, please? The basic building block of a digital circuit. Mayappan, what is the answer?
Basic building block.
Basic building block.
Basic building block.
Block of a digital circuit.
I'm not sure, sir.
Just explore, man. Don't say not sure. Just try to find out. You have a chat GPT, correct now? You get answer.
Sure.
Because you are in the online, you can make use of your chat GPT. This is not an offline examination. Basic building block of a digital circuit. Let me see your answer.
Logic gates, sir. Logic gates, sir.
Fantastic, Chintala Varshita. Logic gate. See, all of you give a big round of applause to Varshita. Logic gate. Very good. Well said. Well said, Varshita. Not and not and or, NAND, NOR, then XOR, then XNOR. You understand, Varshita? These are all the basic gates. X bar. This is what inverter, not gate. Then let me take next one, and XY. Then X plus Y. Okay. Then you take okay. Then this is what and this is what or, NAND, NOR. Okay. Sorry, no bubble actually, no bubble, please. Then XY, then the plus within the circle XOR. Okay. XY bar plus Y X bar. Then XNOR. Okay. What is XNOR? I'll tell you. What is the Boolean expression for this? X into Y plus X bar into Y bar. Am I right? So these are all the basic gates. As I said, if you take any logic circuit, the basic building block of this is a gate. Which is a gate? Example. All the gates are the classic examples of combinational circuit. Output is depending on the present input. Instant input, I should say. You understand? And I put a question to you now. X XOR Y whole bar is equal to X dot within the circle Y. Okay, can you prove this? Each one of you should do it. I should say like this. The question is prove this statement. Prove. Prove this statement. Prove this statement. Wachita, can you prove this? Come on, fast. Satyam Vijaya. Can you get this answer? Can you get the answer for this question? I give 2 minutes time. You got it? Hello. Mayappan? Mayappan. So then what we should do? Hello.
Yes, sir.
You got the answer, man.
No, sir.
Can you do it? Now my question was x or y whole bar equal to x nor y. So then what you should do? First you take x or y equal to, we can write it as x into y bar, then y into x bar. We can write like this.
Yes.
In the next step, x or y whole bar is equal to x into y bar plus y into x bar whole bar. You understand? Then how to simplify this? How to simplify this is that we have a Boolean principle x plus y whole bar can be written as x bar dot y bar. Please understand. We can write like this. Same logic we can apply here. Plus, this is one component. This is another component. Then it becomes like this: x into y bar whole bar dot y into x bar whole bar. What do you say? Correct? Huh? Now, again, let me take another concept: x into y whole bar. Then this becomes x bar plus y bar. Okay. Then this equal to x bar plus y double bar dot y bar plus x bar bar. You understand? Then these two bar cancel. Then finally we can write like this: x bar plus y like this. Then multiply this: x bar plus y into y bar, okay, plus x1. So now what happens? Then this becomes 0. This becomes 0. You understand? This is nothing but this. Is it clear? One of you respond, Mayappan. Varshita, is it clear?
Yes, sir. Clear.
Yes, sir.
Very important. Please note down. Okay. So what we learned here, the basic Boolean principle, please understand. X plus y bar. X plus y whole bar can be written as x bar dot y bar. In the same way, x dot y whole bar can be written as x bar plus y bar. And one more thing is that x into x bar is equal to 0, a into a bar 0, b into b bar 0. Then x plus x bar equal to 1. Please keep it in mind, these things, very important. Is it clear? Okay. With this now, I will move to, this is one thing. The next is Boolean expression. What is Boolean expression? The types of Boolean expression. The types of Boolean expressions. One is SOP, sum of product. Second one, product of sum. Please understand. The sum of product and product of sum. Sum of product and product of sum. Sum of product, you say sigma m. Okay. And product of sum is pi m. Pi m. What is small m? Min term. And we can call it as a max term. Max term. Min term, max term. Got it? Types of Boolean expressions. Max term. Okay. I'll tell you one example here. And in the min term, suppose if you take any variable, say for example, a is equal to 1. You know, 3 hours match. 11. A equal to 1 and A bar is 0. In the pi m, A is equal to 0, then A bar is equal to 1. Okay, one example I will tell you. F of ABC. That means this function is depending on 3 variables. A, B bar, C bar plus A, B, C bar, then A bar, B bar, C, something like this. Then what is the meaning of this? I say 4. What is the meaning of this? 6. It is 1. You understand? So this is what min term. Then how I am going to write this? So this is one product. This is another product. This is another product. Sum of these products. That is what sum of product. Sigma m. Sigma m 146. Okay. I will tell you one example here. 0. In min term, how do you write? A bar, B bar, C bar. Same thing how I write in max term. A plus B plus C. You understand? Then 1. A bar, B bar, C. A bar, B bar, C. A bar, B bar, C. Then how do you write this? A plus B plus C bar. ಫಸ್ಟ್ ಬಾಲ್ ಔಟ್ ಆಗಿದ್ದ ಅಲ್ಲ ಫಸ್ಟ್ ಬಾಲ್ ಔಟ್ ಆಗಿದ್ದ ಫಸ್ಟ್ ಬಾಲ್ then 2 how do you write 2? A plus B bar plus C. 2. Then 3. Four, two, 1. 3. Three, 4. Four. You understand? So A bar is 1. That's what? 5. What is 5 here? A bar plus B plus C bar. 5. Then 6. 6. Then 7. What is 7? You understand? This is very, very important thing. So you can say this is what min term. And this is what max term. Min term and max. Is it clear? Vashita? This is very,
Yes,
very
sir.
important. What is min term and what is max term? Got it?
Yes, sir. Got it.
Now, one small question to you. Can you prove this concept? Mi is equal to capital Mi bar. You understand? That means min term equal to bar max term. Min term max term. Can you prove this? Max term. Say for example, I take M7. What is M7? If I say A bar plus B bar plus C bar, then whole bar. Then how to simplify this? This is what M7, sorry. Okay, we can put it like this. Then it becomes like this. Okay. Then M7 bar M7. Correct, na? What, Varshita? Min max term bar equal to min term. You agree that point? Mayapan Gokul? Hello?
Agree, sir.
Yeah. Now I put a question. You represent M15, man. Represent M15 quickly. M15. Max M15. How do you represent? Can you write M15? How do you write? So M15 means we required 4 variables. This equal to, we can write you understand A bar plus B bar plus C bar plus D in max term. Okay. In the same way, M15, small M15. You understand? You got it? The difference between max term and the min term. Now I come to an example. Say f of ABC, say for example. What we can notice here, f stands function of 3 variables. That's what it means. Then this equal to, just an example, I say A, B, C bar I write, then B bar, C bar, then I say AB. You understand? So in this context, I considered A as MSB, most significant byte, and C is the LSB, least significant byte. So if this is the case, we have to follow like this. But here in this product, we are able to see all the literals A, B, C in the complement or non-complement form. But here A is missing, here C is missing. Then here is A is missing. A is missing. Then how to bring this? A, B, C bar. Then which is missing? A is missing. I'm going to bring A like this. A plus A bar. So B, B bar, C bar. So A plus A bar is equal to 1 here. Plus AB within the bracket C plus C, C plus C bar. Because the value of this is 1. You understand? A plus A bar. So the meaning will not change. The meaning will not change here. So we can write like this. In the next step, what we write, A, B, C bar, then it becomes A, B bar, C bar. You agree? A bar, B bar, C bar, correct? Then ABC plus ABC bar. You understand? Then ABC bar, it's repeating. It's a duplication. We can avoid one thing. That means the value of this is 6, 4, then 0, then 7, 6. There are 2 duplication of 6. This is what we call redundancy, redundant factor. We can eliminate this. So then you can say AB, C bar, then it becomes okay. You understand? So this is what. So what is this process? I say in the beginning it was not in a standard form. Please understand. This is what we call non-canonical form. Non-canonical. Canonical. What do you mean by non-canonical? It means non-standard expression. What do you mean by non-standard? In the entire expression, if you found any product in which one of the literal is missing, say for example, if you take this product, we don't see A or A bar. If you take this product, C or C bar is missing. That is why it is called non-standard form. The question arises how to convert non-standard form into standard. This is what we have done. This whole process is nothing but a conversion of non-canonical sum of product into canonical standard sum of product. How we have done without changing the meaning of the expression? Look at this statement. We made some adjustment by using appropriate Boolean algebra. Say A is missing. That can be written as A plus A bar. So 1. So C is missing. C plus C bar. It will not change the meaning. What mathematics says, you write whatever you want, man. I don't mind, but don't change the meaning of the expression. Maybe if you take this expression here, I can add, suppose 1 is there. I can add n number of zeros. Who bothers? 1. Maybe I have added 100 zeros here, but still the meaning of the expression is 1 only. No problem. It is accepted. But we cannot write like this. 1 0 0 0. My goodness, 1 becomes 1000. No, we cannot write like this. But this is accepted. This is what mathematics. That is what I have done. Maybe still I've written something A plus A bar nonsense, but it will not change the meaning of the expression. You agree that? That's what I've done. So this process is what I said, non-standard to standard. What, Varshita, what do you say? Mayappan? Hello? Nobody is responding.
Yes, sir. Understood.
Very good. Fatima? Fatima, you are from which place?
Sir, I'm from Hyderabad, currently in Bangalore.
Bangalore. Where you are staying in Bangalore?
In Nagavara, sir.
Nagavara, Bangalore North. Fatima?
Sir?
Yes or no? Bangalore
What?
North.
Ah,
North.
yes. Yes, sir.
Very good, Fatima. Okay. Santosham. Santosham. Are you Santosham? Shyam, Vijay, Apurv Ranjan.
Yes, sir.
What man, Apurv Ranjan?
Yeah.
What do you say? How things are going on, Apurv Ranjan?
Fine. It's good.
So far, how was my class now? Was it okay?
Yes, sir. It was fine.
Fine. Are you able to understand what I'm saying?
Yeah. I'm able to.
Very
most
good.
part,
You are
yes.
from which place? Where you are right now? Where are you sitting?
Right now, I'm in Gurgaon,
Gurgaon. Gurgaon
Yes.
is in Delhi?
Haryana.
Haryana. Very nice
But-
place, Haryana. Any questions, Apur? Basically, you are from which place? Same Haryana, working
native,
location and born, brought up Haryana?
No. Yeah, my native location is from Bihar, but I was born and brought up here.
Haryana, Bihar are all neighboring, no? States nearby, quite nearby, no?
No. Bihar is like northeast. Go
Very
towards
far, eh?
Yeah,
Very
I
far,
have
you say?
1,000 kilometers difference.
1000 kilometers, quite far away. Very good. The moment you say Haryana, one thing I remember, Ranjan, the great cricketer Kapil Dev is from Haryana. You know,
Yeah.
you watch cricket, you play cricket, man.
I used to.
Used to, very good. But you like cricket, correct?
And I like football better.
Okay, but you also at the same time you watch cricket, na?
Yeah, sometimes I do.
Good, because Kapil Dev is great all-rounder. The country produced. I think you might have seen him in the commentary box. Apur
Hmm.
Ranjan.
Hmm.
If you go back 1983, I think I hope you're not born that time. The first time the India lifted World Cup under his captaincy.
Yeah.
That was a great moment, I say, because great all-rounder, is a good batter, good bowler, good fielder too. And according to me, is one of the finest all-rounder the country produced. Today we talk many places, many people. Bumrah, so many people today, but Kapil Dev looks something outstanding. Apur Ranjan, you know, he is from
Yeah.
Haryana.
Hmm.
Good, you also from the same. But I watch cricket, man.
I used to watch until MS Dhoni was in the Indian cricket team.
Okay. Oh, when MS Dhoni retired, then you lost also cricket.
Yeah, my
I think you are a fully fan of.
correct. Yes, for Dhoni. Yeah.
Okay. But one thing I have noticed in cricket, Apur Ranjan, in that game, you don't find such character in any other game. It's a totally mentally game. You agree that the bowler bowls at the speed of 150 kilometers per hour. That speed, the batter gets a fraction of second. He has to decide how to play that ball. Only fraction after pitching. I think you don't find that kind of a quality attribute in any other game. That's why something cricket looks something outstanding, different. You agree that?
Yeah, it's a gentleman sport.
Yeah, and also it's a mixture of, say, for example, today KL Rahul got out 90. He made so much struggle, cool, calm, but finally he could not make 100 because of silly mistake. Even
Hmm.
mistakes matters a lot. If you take your Apur Ranjan is batting, if you want to make 100, I think many things involved: patience, concentration, technique, and energy,
Patience.
everything. Even small mistake, you get him out, you get out, and you have to wait for next match to play again to contribute. What Akash Ranjan, Apur?
Yeah. Agree, sir.
I think that way that sport cricket something looks different for me. Correct, no?
Yeah.
That's good, Apur Ranjan. What is any doubt, man? I think did you understand this process? How to convert non-canonical expression into canonical expression, or I say non-standard form into standard form expression.
Yeah.
Apur Ranjan, you understand?
Mm. Yes, sir. I understand.
Very good. Then your question is how the product of sum. Please understand. This is what sum of product SOP. SOP means sigma m, mean term. Now let me take one example. POS, product of sum. Please understand. Product of sum. How it looks, say, if I say f of ABC, how I write, say for example, uh, A plus B plus, okay. It is not 7. I think what I should do. 4. Like this. Okay, this is what 0, and this is what 4. This is what 6. This is what 7. This equal to pi m 0, 4, 6, 7. You understand? Got it? Suppose Ranjan. I take one example, man. Say f of ABC. Okay. I take one expression like this: a plus b plus c, and another one is a plus b. But this is not the standard. Why? The reason is, if you take this sum expression, one of the literal is missing, which is c. C is missing. Then how to make it? Standard. So then a plus b plus c dot, which is missing here, a plus b, okay, plus c into c bar. We can write like that, c into c bar. Okay. Then how to write this? So now what I do, there is a principle. X plus y into z is equal to x plus y into x plus z. Okay. So now what I do here, I do consider this one as x, then y, then z. A plus b plus c. Okay. Then what I do, this becomes a plus b plus c dot a plus b plus c bar. That's it. See, then this becomes a plus b plus c is nothing but 0. Hey, what is this, man? Again we are getting 0, and this is what? 1. There are 2 zeros. This can be discarded. This can be discarded. That's it. 0, it is 1. Then we can say pi m. You got it? Apur Ranjan,
Yes, sir.
you understand? Got it? Got it, man.
Yeah, understood, sir.
Good. So this is what the conversion of non-standard to standard. Apur Ranjan, what is the time now?
8:27.
8:27. I think you're looking hungry, Apur Ranjan.
I am.
And shall we stop here, Apur Ranjan?
I think we can.
I think we can stop here. So thank you very much, each one of you, Apur Ranjan, Varshita, then Mayappan, Fatima, then Apur Ranjan, and all of you. See you next week. Next week will be as usual. Next Sunday morning, 9 o'clock. Let's connect. Only this temporary adjustment only today because since I had a very personal function. So thank you very much for your support and see you next week, same time, same next Sunday at 9 o'clock. Thank you all. Have a nice
Thank
night.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.